Okay, quick recap of 4.1. Pretty straightforward, pretty simple, but pretty important. If I've got y is some function of u and u is some function of x, and again, we'll just assume all the whole differentiable function of, which gets written out every time in a math problem. If I want to find the derivative of y with respect to x, I need to take the derivative of y with respect to u and then multiply it by the derivative of u with respect to x. Notation wise, we could also say f prime of g of x. Shoot, how do we say that? Y prime equals f prime of g of x times g prime of x. Sometimes this is written as f of g of x. There's lots and lots of different notations just to make things fun. And you can dive into the history of the simultaneous development of calculus in various places and by various people, which is why we have all this. And pretty straightforward. Pretty straightforward. I feel like the most useful one, I like this because it reminds me that there's a g of x in there so that I don't end up writing the derivative of f with a u, and now I've got two different variables. At the end of the day, I really want one variable, one input variable, not two input variables. So I do like that one. So we could say that this is, yeah. Uh, Sorry, lost my train of thought there for just a second. So, and then one more thing that we might talk about is the inner outer. And it's the same thing, but it's just a way to think about these things. If I've got y equals some function of u, this is my inner function, this is my outer function, and so then I take the derivative of outer times derivative of inner. And we got to be a little careful here because this is the derivative with respect to inner. Again, just makes it more complicated. But what's nice about the inner outer is that I can just stack layers of. Let's just look at a quick example, and I'll just make something up. Sine of 1 plus tangent of 2x plus 1. So my inner function is 2x plus 1. There's my inner function. My middle function, working my way outwards, is 1 plus tangent of u. And I'm just going to call this u equals 2x plus 1 because it makes my life easier as I work my way outwards. And then my outer function, of course, is sine of v. And I'm going to call 1 plus tangent 2x plus 1 v. So how do I do this? Well, I take the derivative of sine of v times the derivative of tangent of u times the derivative of 2x plus 1. And of course, I plug 1 plus tangent u back in for v, and I plug 2x plus 1 back in for u. And at the end of the day, I've got this big long thing. Okay, so there's the inner outer version. What else do we need to know? Not a whole lot from this section, except remember that remember that derivative of a trig function assumes radians. Stick that in the back of your mind. Keep it there. Pull it out when you need it. And that is section 4.1. Thanks for watching. Hope you learned something. Hope you're comfortable with the chain rule, and we'll be back with chapter 4.2.